This is Euclid Book 10, proposition number 5. Here's the illustration, folks. Okay. Commensurable magnitudes have to one another the ratio which a number has to a number. Let A and B be commensurable magnitudes. I say that A has to be the ratio which a number has to a number. For since A and B are commensurable, some magnitude will measure them. Let it measure them and let it be C. Okay, so these two lines are commensurable. C measures both of them. And as many times as C measures A, so many units let there be in D. So what they're saying here is that if C measures A twice, then D would be 2. If C measured A 3 times, then D would be 3, and so on and so forth. Okay. And as many times as C measures B, so many units let there be in E. Okay. Well, let's say that C measured B, say, 5 times. Well, then E would be 5. If C measured B 3 times, E would be 3. Get the picture? Okay. Since then, C measures A according to the units in D, while the unit also measures D according to the units in it. So now we're saying that 1 will measure D. Well, 1 measures everything, so 1 measures D. That's what we're going to say. Therefore, the unit measures the number D the same number of times as the magnitude C measures A. Okay? So, if D were 3, then 1 measures 3 the same number of times as C, which C measures A 3 times. That's what they're trying to say. Something like that. Okay? Therefore, as C is to A, so as the unit is to D. Okay? This is by Euclid Book 7, definition number 20. Okay, so now we're going to say, as C is to A, so is 1 is to D. That's what we're saying. Therefore, inversely, as A is to C, so is D is to the unit. Okay? So as A is to C, so is D is to 1. That's what they're saying. Okay. Or that's what he's saying. Again, since C measures B according to the units in E, while the unit also measures E according to the units in it, therefore the unit measures E the same number of times as C measures B. Therefore, as C is to B, so is also 1 is to E. Okay? But it was also proved that as A is to C, so is D is to 1. Okay? Therefore, xi quali, as A is to B, so is, okay, now hold on. As A is to B, so is D is to E. That's what they're saying, and we can say that because of Euclid Book 5, proposition number 22. Therefore, the commensurable magnitudes A and B have to one another the ratio which the number D has to the number E. And that's the whole proof, people. I will tell you more in a future video. Stay tuned.